Question 1. So we've got a man standing in a lift. Here's the lift. Here's the man. The man has a mass of 80 kilograms. The lift is moving upwards with an acceleration of 1.8. So we've got to calculate the normal reaction of the floor of the lift on the man. So here is the man with his mass of 80 and his weight of 80 g, and the lift is accelerating upwards, and there is a force on the lift floor pushing up on the man's feet. Let's call that N. So now if I resolve this picture of the man using up as a positive direction, because that's the way my acceleration is going, then I'll have N pushing up, 80g pushing down, so a net force of N minus 80g, and that will equal the mass of the man, 80, times the acceleration. So solve that equation, and you will find that N, the normal force of the lift floor on the man, is 928 newtons. Question 2. This time we have a lady in a lift, and the lift is accelerating downwards. So let's have a look. Here she is. She's got a mass of 60, and the lift is accelerating downwards. Okay, find the normal reaction of the lift floor on the lady. Right, well, here she is. She's got a mass, and so she has a weight. And she's obviously not in free fall, so the lift is exerting a force onto her feet. So let's have a look. Let's resolve this in a downward direction. So the force is 60g minus n, and that equals the acceleration in a downward direction times my 60. So there is my equation, and if you solve that equation, you will find that the normal reaction there is 498 newtons. Question 3. Two boxes, A and B, of masses 110 and 190 sit on the floor of a lift of mass 1700 kilograms. Box A rests on top of box B. A, B, they're in the lift. Here's the tension on the cable. The lift is supported by a light and extensible cable, and the lift is descending with a constant acceleration of 1.8. Find the tension in the cable. Right, well, I'm going to treat the lift and the boxes as one thing. So I've got a tension on the cable. We're accelerating in a downward direction. Now, the total mass there is the mass of the lift and the two boxes. 2,000 kilograms give me a downward force of 2,000 g. Right, let's resolve that. Let's resolve that in a downward direction, since that's the direction of the acceleration. 2,000 g minus t equals 2,000 multiplied by 1.8. And that gives me a tension in the cable of 16,000 newtons. Part B. Find the force exerted by box B on box A. Right, find the force exerted by box B on box A. Well, let's have a look at box A. Here it is. It has a mass of 110. Clearly, it has a weight. It's accelerating in downward direction at 1.8. Now, box B is exerting a force onto box A. I'll call that X. Okay, because otherwise, if it wasn't, box B would be falling freely. Let's have a think about this, and let's resolve it in a downward direction. So we've got a force of 110 g going down, so a net downward force of 110 g minus x, and that is going to equal 1.8, the acceleration, multiplied by the mass. So x will equal 880 newtons. Part C. No, it's not part C. It's B, part 2. Find the force exerted by box B on the floor of the lift. Okay, let's have a think about the lift. Here it is. Now, there's a tension here of 16,000. We're descending with an acceleration of 1.8. The lift has a weight of 1700 g. And there is a force being exerted on the floor of the lift by box B. I'll call that x. Now, let's resolve this in a downward direction. So I've got forces going down. 1700 g plus x, and then a force in the opposite direction. So I've got a net downward force of 1700 g plus x minus 16,000. And that equals the mass, 1700, times the acceleration, 1.8. So now I can solve that equation to give me x equals 2,400 newtons.